shared with a YouTube link if you sign up for the event, just in case you want to check out more detail about what talked in the session. So just give me half second to make sure the live streaming shared with you. Yep, it's up running. So next I'm gonna share screen and go over our open house slides. Can you see my screen all right? Yes? No? Can everyone see my screen? Well,
looking good.
Awesome. Yeah, we're gonna share the notebook and the video quickly. So David and I both work for a school called NYC Data Science Academy. We are national accredited by ACCT last year. It was a very lengthy process. It took us 4 years to finally get the credit. It means it's a recognition of premium quality in teaching and job placement and across the board how the school is operated. So today you can mainly share through Q&A. You can type anything here and David and I will take turns to answer questions. I believe the chat is not working. Not sure why, but sometimes working is not working. Little bit about the school. We have been running as a Best Data Science Bootcamp since we established. So these are our recent award: Best Data Science Bootcamp from SwitchUp, Best Online Bootcamp from SwitchUp, Best Data Science Bootcamp from Course Report, Best Online Bootcamp from Course Report. It's based on the audience review. I believe we have around 350 review on each of the site. So we appreciate our past students to drop some message about their experience. Okay, so we offer Data Science Bootcamp, which means it's an intensive learning experience to help you upskill to a certain level. We also offer lighter training called part-time courses, professional training course. And we teach both Python and R. There are not many schools teaching both Python and R. And if you join our bootcamp, you will have hands-on learning with individual project and a group project. That's an amazing way to help our students land industry jobs because they practice more skills through those projects. We offer lifetime career support here. So many students graduate like back in 2015, 16 have come back for several job opportunities. And we always have happy to support. With all the alumni we're working with, we have built a really strong connection. So in New York alone, we have 500 companies hire from us directly, more than 1,000 hiring managers in our network. And when our students finish school, some of them become hiring partner and come back to hire with us too. So we're very glad to be quoted as Best Data Science Bootcamp and Best Online Bootcamp. So how does that work? The Data Science with Machine Learning Bootcamp is our signature program. So as you notice, we already start our August cohort and our September cohort is about a month away from now. We also offer 40 hours pre-work program. So if you plan to come to bootcamp, we encourage you to apply as soon as possible so you can get access to the free pre-work program. We launched the Data Analytics Bootcamp in 2020 to adapt to more broader interests in this profession. It doesn't cover as many as topic as data science, machine learning program, but once you finish data analytics program, you can continue your learning towards a more difficult program. So we make sure you have seamless transition between two programs. So the main difference between data science and data analytics program is the machine learning component, big data component, and deep learning component. So as you can imagine, our most popular program, including machine learning, including big data and deep learning. So if you already have some background, typically machine learning bootcamp is a great choice. If you don't have any background, you want to try if data science profession is some good fit for you, you can start with data analytics program. But so far, 90% of our graduates are taking machine learning bootcamp. Even people don't have background, they want to make sure they learn everything they can in the field and continue to grow on this career path. So we offer 3 types of delivery mode. The most popular one is the online program, because you don't need to leave your job. You can finish your coursework with a flexible time plan. And as long as you're putting enough work there, it's gonna work. And the in-person live online is contingent on the number of enrollment. So it's not guaranteed it's gonna happen every quarter. Okay. So the application process is pretty straightforward. You start with submitting an application. We want to know who you are, what's your interest, what your goal you want to achieve here. Then you will be scheduled with our admission officer for an interview, half-hour interview. If you pass the interview, you will be given a tech assessment. It's usually a multi-choices question. You probably can finish within 2 hours. So if you go to our website, you can see those options. The most popular one is apply now under the online program. The same thing with data science with machine learning online program. Okay. So we have a lot of lovely alumni who has become our extended family, and from different background, different location. We have alumni across the board. As I mentioned, we have students from Amsterdam, from South Africa, from England, from everywhere. So we're really glad to attract this many talent to join us. And if you have any question, you can email admissions@nycdsa.com. We welcome you to contact us. We cannot wait to hear more from you. Okay, that's my part. David, you can take over. And let's officially start the Pandas session.
Thank you, Vivian. Let me just share my screen here. All right. Move some things around. All right, well, we're going to have kind of a quick overview here of a lot of things that you can do with Pandas. So for the 2 of you, that one of you has a computer science background and the other one says they have many Python certificates, this may be a little bit redundant in some parts if you already have knowledge about it. But what I want you to take away from it, even if you already have the skill set of how to code or how to do some of the operations that we'll see today, is more of the thought process when going to approach a project, building one for yourself and trying to showcase it to employers, or if you're working at a company and you want to be able to think critically about whatever it is that you're working on, right? The main thing when it comes to building an application, solving some kind of problem, is really having a good hypothesis or a good challenging question, guiding question that you can ask in order to come to some kind of solution. Some people try to start with the data first and just see what they can explore and do with it. But the real benefit of data science to the world is being able to look at questions or challenges that we face and trying to tackle those kinds of things. So come up with the question, start framing whatever the problem is and approach it from that light rather than just grabbing for things, rather than formulating some kind of good guiding question. And so we're going to be doing that as we go through this Pandas walkthrough today and doing some data manipulation and visualizations later on. And we're going to be doing it from the point of view of looking at some data from the CDC, right? 2018, it came out with a report and a data set essentially, which is rich in information about births and certain characteristics that might affect whether or not this child has a predisposed risk of going into the ICU based on different characteristics. So its data is very, very rich, meaning that it has a lot of features. There's a lot of columns or information about any given observation. And so it can give us an idea of what might happen to this baby, given some current characteristics of what's happened during its the trimesters of the mother, right? And so some of the things that we want to take into account, which we'll be looking at today, is the number of cigarettes that the mother has smoked in different trimesters, and what percentage of those have gone into the ICU after being born. Keep in mind, we're really only going to look at a small subset of the data. The data itself is roughly 3.8 million rows or more than that. And with our limited operating systems on these computers, it's a lot more than we can handle. And we're not going to be using any cloud services today. We're just going to be looking at a 1% of the data, which is roughly 38,000 rows. So any of the kind of claims that you might see here today, or the things that we're analyzing, we can't take it as ground truth, and we can't necessarily say these assertions will hold true. They're just in the frame of view of looking at a certain subset and trying to come to an analysis or certain conclusions through that, right? And so, like I said, only 1% of the data, it may not hold true, and you might see for any of the numbers you run, particularly towards the end, if you're going through this notebook later on, you might find that the percentages that you see are different based on whatever way that they were indexed, right? So keep that in mind. And you also want to have that as a frame of reference when you're building your own data science projects and you want to instantiate certain claims. You need to make sure that they're actually analyzing the accurate population of the data, and it's not some just individual subset that might have a one-off value and say, oh, this is representative of the whole population. You need to be careful in making certain claims like that. So what are the topics that we'll cover? We're mainly going to be focusing on the Pandas package, which stands for panel data. And it's good for doing things like reading in CSV files. If any of you are familiar with that, it's essentially just tabular data. Stands for comma separated values. And those are the file types that we're going to be loading in with this today and working with, like I said, a subset of the data. After we do the reading of it, we're going to do some inspecting and manipulation. How do we look at certain statistics of the numbers and get a rough idea of what's happening in the distribution or the features that we're working with? And after that, how do we get into grouping and aggregating the information? In this case, we're particularly going to be looking at how many number of cigarettes contributes to, like I said, increased risks of babies going into the ICU. So given a number of cigarettes that the mother smokes in a particular time frame, what is the percentage chance that the baby will go into the ICU? And then finally, with all of that, now that we have some grouped information, it becomes much easier to understand what the story is when we're actually visualizing it. With just looking at tables, I mean, I could put up a huge table of the data set in front of you right now, but most of you, your eyes will probably glaze over, you'll lose interest, and that doesn't matter. But if I put up some beautiful looking graphs, you're probably more engaged, you have an idea of what's happening in the data set, you can assess the overall story, and it condenses a lot of information and helps us to get at what the true answer of the question is that we're trying to ask. And if at any point you have questions, please send them in the Q&A section. If you want to say them out loud, just pause me and ask away, and we'll try to make this a little more interactive. But for the most part, there'll be some stages where I'll just stop and make sure you've digested what I've got to at the section. And if you have questions, we can stop for that. So although you can download all of the packages that you want, as many as you want, think of this kernel that we're working in, right? It says IPy kernel here as an isolated environment, right? We don't want our computer to do unnecessary work. We really only want to work with the packages that are specific to whatever kind of analysis is that we're doing, right? We don't want to load everything in, have our computer doing a bunch of computations and things allocated in memory. We just want to isolate it to the things that we need. So this first statement that we see here is just importing NumPy. NumPy is working with arrays, or basically series of information, and Pandas is going to be built on top of that. So a data frame that we'll be seeing later on is a number of series put together. And so when working with a package, you start with whatever the name is, right? So we had it already downloaded. If any of you don't know how to install a package, it would just be pip install. and then NumPy, and this will pull it from online and it'll install it, but I already have it installed, so I'm not going to run that. But in case any of you aren't familiar with how to download a package, that's how you would do so. And so when you have a package, there's a number of functions that are inside of it. And sometimes a package is even a collection of other packages, right? But in order to access some of the elements that are inside of it, the functions that we're going to be utilizing, you just need this period, right? So we're basically saying, go inside of NumPy, right? Open up the container that this is NumPy and what it facilitates, and find me the square root function, right? Hopefully we all know what this does. But basically we're just saying, take the square root of 16. And so 4 squared, 4 times 4 is 16. And so this is the value that's going to be stored inside of this variable here, right? And we're just naming it with square root of 16. This is the assignment operator here. And we're just saying to take this value, put it in this bin over here. Keep in mind, as we go through this walkthrough, that a lot of the functions and operations that we do are non-mutating, meaning that there's still going to be the original object. So think of your Excel table, right? We might be changing it, we might be manipulating it, we might do some certain operations to it, but that original table is still saved the way that it is. We haven't changed anything of it. We're just outputting a new table that does whatever the operations are that we look at, right? So here we want to say that we want to print something. This just outputs a string to the console, a string being something that we would know is a sentence, right? And this here is a F string, or it just stands for a formatted string. And essentially we're saying we want to have this whole sentence here, but we want to insert some other values. It can be a math operation. I could times 2 values in this place. We're just saying that this is not going to be more like a string. It's going to be some kind of number, but we want it to show up inside of the sentence that we're creating, right? So we have print, and the square root of the number 16 is, and then whatever this value is that's stored inside of this square root 16 variable. There are a number of basically constants, and pi being one of them. We all know 3.14. And so these are common constants that are used inside of other functions. So those numbers are saved in the package as well. So you can just go inside of NumPy and pull out the number pi. And so it's just showing the same thing here, where we have pi to 15 decimal places, because that's the number of decimals that they decide is a good number to look at here. And so like I just said, that's an F string, meaning that we can format it, we can insert other values into it, and change some of the things that are going on in it, right? Any of the things you want to look for inside of a package, the functions that you want to utilize, they're just going to be in NumPy dot, or whatever package is that you're using, the thing we want to use, right? Whether it's another function or some kind of attribute. Objects have the same functionality of this, and we're going to see this later on, that when we're working with the data frame, it also has methods and attributes that can be accessed by this period here. But in the case, we're just doing the NumPy square root, and we inserted 16 into it, or we just pulled out the value of pi. And so convention stands that we don't just want to use the name of a package, because we're going to be referencing it a lot. And so coders will essentially try to make things as much shorthand as they can. And in this case, the convention stands that NumPy is just as NP, and this here is just an alias. Essentially, right, my name is David, but some people call me Dave, and that's an alias for David. It doesn't mean that my name has changed. People can refer to me as either. But in this case, it makes it a little bit quicker and easier to access it. I only have to do 2 letters instead of the 5. Not too bad there, but some of the other packages that you can look at might have, does the same effect and just tries to make it easier when typing it through. And so here we just reference it the same way we would have before, but now we do it by the alias that it is rather than the full name. And so if we're typing this over and over again, it saves us a lot of keystrokes. And if you're out there in the wild and you're looking at someone's code and you see NP, what's that? I've never seen it before. Now you know that it's NumPy. And so Pandas, like I said, built on top of NumPy, also built on top of matplotlib, which is for the visualization aspect. We'll see that later on. And so we just want to import Pandas as PD. Another shorthand here, we don't want to keep referring to it. This here is a function call. So at the end of it, we got to have our parentheses, and it's just showing us the current version of the package that we've installed. And so a lot of this isn't too useful to you right now, but as you start to work with other versions of operating systems, computers in general, if you have Mac or Windows, and now the Mac's got the M1 chip, so there's all kinds of versions out there. You have to be aware of which one you're using, because different packages, as they get updated, a number of things will happen, right? There'll either be a version conflict, meaning that you need to update your operating system in order to install the latest version of it, or you'll run into conflicts where it's using another package, right? We can see here that Pandas, including in this PD show versions, that it is kind of coupled with NumPy. So if you want to update one version, you may need to update the other. So you won't run into any version conflicts, and it will say, oh, can't use these functions. Another thing to keep in mind about installed versions is there's a word called deprecated. And essentially that just means, and they'll give you a nice warning, thankfully, even though this is open source and it's free, there's still a number of sanity checks that happen to give you kind of a safeguard when things might go wrong, right? And so deprecated just means that maybe a particular function that was in this version is no longer going to be in a version in the future. And here we're giving you a warning to make sure that you're aware the name has changed or the utility of it has changed. And so when that happens, be prepared and don't go looking for it because it's no longer there. So those are some of the things to keep in mind about version control and the way that you would access different things inside of that, right? Another thing that we could do is dir, which just stands for directory. And essentially this will tell you a number of the functions that exist inside of the Pandas package and things that we can operate with. For the most part, we're going to be utilizing the data frame, which, like I said, is a tabular data, or think of it as Excel with rows being observations, columns being features, or a characteristic that tells you something about that observation, right? Like I said, we'll be looking at births, so a number of features that contribute into how that birth went. Any questions on those things so far of version control, packages, anything of that nature? All right. So like I said, the data that we're working with comes from the CDC, and it's this 2018 data set. And it's sampled only 38,000 observations of the entirety of nearly 4 million. And so the way that we're going to load that in is we're just going to do PD again, as stands for Pandas. We're going to read in the CSV, and we're going to denote wherever the file location is. In this reference, that I've put it inside another folder called data. And we can see that here if we're looking at my Jupyter notebook. We can see that I'm in the data manipulations with Pandas here. Inside here, I have a data folder, which has a couple things. We're going to create this in just a moment, but this is where my data is located. So I have to reference that when I'm saying specifically the file path that I'm going into. Another thing to keep in mind on this portion here, you'll see this in R, you'll see this in Jupyter Notebooks, is you want to know your file path, or you want to know your current working directory. And essentially what this means is this is the space in which I'm working. When I save a file, it's going to be saved inside this folder. Sometimes when you're working in R, it'll start off in your C drive, your root directory, and you'll create a file, you'll create a script, you'll save it, and you'll look inside the folder that you're working with, my data manipulations with Pandas, and I'll go, oh no, where did my file go? And so it's very important to know the space in which you're working, because that's where your files are going to be saved. And when you see functions like this, that's how you're going to reference them, right? If I just had it inside the folder that I was working in, I could just reference the file name and it would load in the data likewise. But now I've saved it in a subfolder called data. So I have to be explicit about saying where that location is. If I'm not, then we'll just run into errors, right? And it'll say, I get this error warning, things aren't working the way that they should be. Keep in mind, right, we don't really show it here, but there are some default arguments, right? And what a default argument is, we can essentially see that this would be the file path. One thing that I can hit is I can hit Shift Tab when I'm inside the function call, and it'll show me a number of things, i.e. the arguments that this function takes, right? So it has a file path, which I don't have to be explicit about saying this is the file path if that's all that I'm referencing, but it has other things like a separator. What are the values inside this file separated by? Does it have a header, right? And so does it have column names? By default, it's going to infer them. But if I said that this was none or false, it would just essentially give me the same as it has here for the index for my column names. And then my first row would be the column name, since in the file, that's where they were positioned. And so we save this data after we load it into the data frame. And in this, we can just call it by itself. Essentially, the Jupyter Notebook knows to output whatever that object is. So I can just run this cell, and I see that we get all of the tabular information. And so there's a lot in it. Even though that there's 38,000 rows, it's not going to show all of that to us, right? There's 108 columns, and we get this ellipse of 3 dots, and it essentially means compressed inside of there, there's more information. So don't think that you're looking at the whole of it. You're just looking at a certain section of whatever it is. Inside here, again, each row would be a birth, and we have different characteristics on, attributes that relate to that birth. We have the year, the month, the time of the birth. We have the week, the place, the mother's age. This here says mother's age imputed. I don't see any values for it, but essentially what imputing is in data science is something that's necessary because you might not have all of the information, and you find a logical way of inputting values to kind of simulate a result. If you don't have the, right, if somebody left out their age, some ways of doing that is a mean impute or a median impute. We just take the middle age and throw it in for that missing value. And we have all kinds of other things, right? The defects that the baby may have been born with, and some other things related to, like I said, the state of the birth at that time. So just as this is a subset of the much larger data frame that is 4 million observations, the reason why we do this is not only to reduce computational time so that we can take a subset, make inferences about the population, but maybe there's a specific case that we want to look at to kind of narrow in where it is that we're doing an analysis, right? And so it's truncated, it's a smaller version of what we're doing. And sometimes we just want to look at particular columns, right? We don't want the 108 columns that were in our data set. We just want to look at maybe the number of births for any given year or month or weekday. And the way that we would do that is we create what is called a mask. Essentially, it's basically saying, what is it that we want to filter our data with? What is it that we want to reduce it down to so that we only have a particular subset of that, right? And so here we're just saving this list. It only has four values, the birth year, the month, the time, and the day of the week. And so we're essentially saying, all right, we have this larger data frame. We only want to grab out these columns. How do we do it? We just index this data frame by the name of the columns. And that's what this square brackets are, right? Here I said it's a list. In this place here, it's basically saying, take that list and index the data frame by these values here. And again, this is the dot operator here after the data frame. So essentially it means that it's either a method or an attribute of that object. And what does that mean, right? Well, I'm a human, so think of me as having attributes and methods. And so attributes would be basically returning a value. If you said, what is my weight? It might return 170 pounds. It doesn't do anything. It's not a function. Method is just another name for a function of an object. So some of the methods that I might have are run, walk, speak, things that I would actually do, right? So you got attributes, which return values or some kind of maybe a sentence about me. And then you have methods, which are things that I might do as a function. And so inside this data frame, after we've taken just those 4 columns, we're going to say get a sample of 2000. And so this takes a random normal sample. Essentially all that means is that it's randomizing the way that it samples the data so that hopefully we have things that we can make an inference on the population of, right? It's not just the first 100 rows, which might have a particular pattern to them in itself. We want to know something that we can make inferences about the population to. So we're going to do a sample or a random normal here of just 2,000 values of that 38,000 that we had before. And so, right, if I run this again, we can see that where the birth time is and the weeks, those values are changing, right? Because each time it's taking a different sample of 2,000 values. And so each time I run it, when you guys run it later on, you're going to see different values for the ones that are currently here. And we can see that it's exactly what we want. We have 2,000 rows by 4 columns. And so maybe this wasn't that involved right now, but it's very important to save your work, right? Because like I said, all of the operations that we're doing, unless we have this assignment here or something that you'll see called in place, that's another argument called in place. If that's set equal to true, that operation will happen to whatever the original object is. But when I do this here and I subset it by the columns and I take a sample, this is a new data frame that's output. It's not the original data frame anymore. We've done some operations to it, but we're outputting a new data frame. We're not going to manipulate the original one, and that's helpful. So be careful where you have these assignment operators, because if you run it too many times, maybe things have changed, and now you're referencing the manipulated version of that, and that can cause problems when trying to assign it back. Because it's always good to have version history, right? To know what was the original data frame, what are the operations that I changed of it, and keep those two things separate so that if I make a mistake along the way, I can just trace along the breadcrumbs and figure out where I made my mistake. Like I said, maybe this isn't as involved as it could be, but we've done some operations, we've come to a subset of our data, and now we just want to save it back to a CSV, because if I turn off this notebook and I turn off my kernel, when I open it up again, everything, think of it as a fresh slate. I have all of the code, but all of the things that I've created by running it have to be run again. So, if you've done a complex modeling process and you found some unique characteristics, you want to have that saved, because you'll start it all over again. And sometimes when it comes into the advanced modeling, if you're working on your home computer or even larger computers, it can take hours to generate models. And so do I really want to have to do that all over again, go back to sleep and hopefully it's stored there. And so this line here, it's taking the subset data frame, it's sending it off to a CSV. What are we calling it? We're just calling it df-write-test.csv. Remember to use the file type afterwards, so it saves as that file type, not just the name of it. And so this is the one that we saw here. Inside this data, we have df read CSV. I can take this and I'll just delete it, get rid of this. Just a proof of concept here. Run this again, come back over here, and boom, seconds ago it was created and we have this file back. And again, all of that's because I'm specifying the file location and what it is that I'm working with, and I'm in the current working directory. Throughout the bootcamp and in the start of it, we'll learn Linux commands, and essentially, if any of you have messed with the console or the terminal, this is our code specific to the Linux and the terminal that are going to help you relate certain things. So right here with this exclamation, we're essentially saying that this is going to be a Linux command. ls is going to be for listing off the objects in that environment, and we're going to say do it for all of the ones that are in the data folder. So when I run that, it shows the different things that exist in there. This neat little blue one that showed up with the dot in front of it, this is a hidden file. Essentially, this is what's keeping track of all of the things that I've done here in terms of the cells that I've run in the output. So like I said, if I open this file again, it's going to show me what the output is, but technically that's not in my environment. It's not created yet. It's just like a picture of it. So I would have to run it again if I want to be able to do some operations with it later on. Again, this is just showing what it would be if I change the header argument to none. And so now the first one here, right, is just the name of the columns that we had. Not super helpful. We just get these integer values for the column names. So keep in mind that if you don't see it, right, if this is hidden from here, there's still arguments inside of here that are contributing to certain things, right? And we can see that with the equal sign and whatever it is to the right of it, this is going to be the default. So essentially it's just saying there's no delimiter or there's no index. So it's going to generate one for us. And if we do that the same as we did, so the same as the default with the index, if we set the header equal to none, we're just going to get the first row in the CSV is going to be read in as the first observation there. Any questions on loading in data, reading data frames, saving them? All right. So now that we've loaded in our data, we've looked at whatever the information is that we have, it's really a good practice to start inspecting it from the beginning, because it'll give you an idea if any values were input wrong. Maybe someone has loaded things in as the wrong data type, and in order to do certain operations, we need to be aware of those things, right? The way that we group certain things is affected by that. The way that certain math operations happen is affected by the data type. And so as a first pass, again, sometimes we just want to look at a certain section of the data that we have rather than it as a whole. So some really quick functions in order to do so is the head, the tail, or sample. In this case, it just gives you the first 5 observations here of the data frame, and the tail is the last 5, right? And maybe as a first pass, you just want to look at the first 5 to get a nice understanding of the values that might be inserted in there, and some of the types, just so you can do a nice first pass at seeing if they are in there correctly, right? Were they living at the time of the birth? Were they transferred somewhere? And these are just yes or no, but these, in order to be operated on later on, it's probably best to denote those as 0 for false, 1 for true, right? And put some of those as such. And then we have other things in other columns, right? The time, this might just be the hour and second, or the hour and minutes, and things of that nature, right? For sampling, again, this is what we saw earlier. We just did a sample of 2000. And we want this base one to be replace equals to false. We don't want to have any duplicated information, right? We don't want to say that the same baby was born twice, unless it was a twin, right? Maybe, but they're going to have different characteristics in terms of the weight. And so we want to say that the replace is false here. We don't want it to be the same observation over and over again. And then for the other part of that, we have to specify n, or we have to specify a fraction of it, right? How many observations do we want? Before we wanted 2000. In this case, we may just want a fraction of it, or 10%, something of that. So like I said, the head's just going to show you the first 5 rows. The tail is just going to show you the last 5 rows, and we can see whatever the index is here to confirm that. Keep in mind that Python is zeroed index, meaning that it starts at 0 and starts counting after that, right? Things like R start at the index of 1. So there are some nuances there that you have to keep in mind when working with this. We see the sample here of 1,000. We can confirm that down here. There's 1,000 rows, same amount of columns. Or we could do a fraction, right? 50%. We want replacement to equal true. So there are going to be some cases where we do see the exact same observation. We don't see it here by chance on the first or last 5, but know that some of the ones that are in here, especially when it's only 38,000, we're taking 50%, are definitely going to be repeated values. So, question: does the system know what head and tail represents? In terms of, just the same one. Essentially, this is going to be, like I said, if we looked at the directory of inside of what a data frame can do. If I go into, let's show this here. Right. Data frame. inside here, you would see different function calls for looking at the head or the tail of it, right? Here we can see head. There's a number of other things that we can do. We'll get to these group by later on. So essentially, we're just saying this pandas data frame. And so keep in mind, when you're trying to look at things like this, if you're trying to look at the documentation for it, you need to have the explicit reference of whatever that object is and how to access it. So you need to reference the package first, and then you need to reference whatever that object is, and that's when this is going to be output, right? If I just do this df here, I also get it because it's one of the objects in my environment. So it depends on whether I'm looking at the base class of it, or I'm just looking at an object that I've already created. But if I haven't created this df object, there's no way that I'd be able to see the directory of it or the things that exist or it's able to do. So for these heads and tails, or the sort values that we're going to get into here, the way of which we know that that functions is looking at the directory, seeing the ways that or different methods or attributes that that object has, and then utilizing them, right? Another very helpful thing to look at, just in reference to that, is the doc string or documentation for it, right? And so if you put this question mark in front of whatever the object is that you're looking at, you can see all of the characteristics of it. They'll tell you a brief description of what it is. They'll get into the parameters that it takes. What do those parameters mean? And if you scroll all the way down, they'll have versions of what it is to create that kind of thing. Yeah, absolutely. All right. And so again, utilizing some things like this, the question mark or the shift tab inside of the parentheses, will help you answer your questions a lot quicker than maybe scouring the web would. And so it should be your first pass at trying to figure out whatever this object is and what can I do with it. If it's a squirrel, what does it have? It's got seek the walnuts that it's looking for, and it sniffs them out, and it's got play and some other things. And so everything in object-oriented programming is thought about as an object, has certain attributes and methods, and that's what we are utilizing here for this case. And so this other one is just sorting the values. And this starts with ascending. So we can see we had this whole data frame here, and we just said to sort by the mother's age. It starts at 13, unfortunately, goes all the way up to 50. And so this is the values of these observations here, sorted by the mother's age. And so that's just one way of starting to assess the data that we're working with, right? Maybe we're looking at customers and we want to know certain characteristics, right? What are our top 3 customers by each month? So we would need to sort, we need to aggregate by month, we need to find the top 3 values. And so those kinds of process or thinking about the steps that we might run into, or why some of these base operations are done. And later on, we're going to see how to chain them together and make some comprehensive code here for it. So we can sort by multiple columns, right? We can sort by the birth month and the mother's age. And then we can do this here, which is essentially what we saw before with having a list of columns that we want to reference. We're essentially just saying these 2 columns are the ones that we want. If I didn't have this, it would show us the entire data frame, but we're just more concerned about showing how to sort these things. And so the placement of these matters as well. It's going to sort whatever one's listed first, and then the second one. So birth month, it's going to start with 1 through 12, but it's going to start at 1, then sort given whatever that month is, the age within it. So if we saw the month of 2, it would start over with whatever the lowest age is, right? And sort an ascending value. So if I have the mother's age in the first spot, and then the birth month, right? What's going to happen is it's sorting by the mother's age first. The way that we index these was the same. We're still referencing birth months first and then mother's age. So now that we can see it changed, right? It's starting with the lowest age, and then it's doing the age of 14, but then cycling through whatever the month is there. So the order of these matters, and whichever one you list first is the one that's going to be sorted first, and whichever one you index first is going to be indexed first, right? And so good, just keep, you can keep throwing questions in the chat, and I'll try to get to them as we go through this as well. The next thing we look at is merging, right? Because it's not often the case that you just have your data in one place. It's nice and easily accessible. It's often in many places, and we have to bridge the gap. How do we look at many different data sets and reconcile those and put them all into one so that we can make better, a better analysis? In some cases, it's called an enrichment data set. Essentially, I have a lot of characteristics of the babies and the individuals, but maybe now I wanted to find what are the proportion of different demographics in that area, different income in that area, education levels, and maybe see how that affects the analysis that I'm running. So maybe I go to the census data and I look for those districts and I try to merge those two together. And so in this first case, we're just essentially showing how to create a data frame from scratch. And all of this, it's going to be stored in this much bigger list, but each of the elements inside those are a list in it themselves. So a lot of inception going on here. It can be kind of confusing, but just when you start to look at it, you need to break it into smaller sections, and that'll really help you start to understand it. So the first item here is just Sunday and the number 1. The next row, and this is where we can see that it references down here, is Monday and 2, etc. We're just labeling the number of the day as it comes in the week. And then we have to be explicit about our columns. First column we have, which we can see here, is the days of the week. We just call it the name for the name of the weekday. And then the number here for whatever day of the week that references. And so when we output it, we get a nice little data frame, much smaller than the one we've been working with up until this point. It has the name of the weekday and then the number that's associated with. But the reason why we do this in some smaller cases is because we want to connect it back to a larger data frame, and we want to change those values, right? Like I said, we're going to be getting into aggregating. And so when you have aggregate, or when you do group by and then aggregation, you need something that's categorical, right? Categorical meaning that it contains a bunch of categories. In this case, it's just the day of the week name. But I don't want to do that with the number here. I want to do that explicitly with the name so that I can see perhaps the births in the week, the number of births per given day. And I don't want to reference it by this because this could be arbitrary. Maybe someone started with Monday as number 1 and I have no clue that they did that. So in this case, it's explicit saying the day of the week. A few things that we have to keep in mind when merging are what's our left data frame? Excuse me. Essentially, what is the table that we currently have and are working with, and what are we combining it with? And so we have our left data frame, and this is generally the main data frame. You can do left joins, meaning that we keep all of the information from the left table, and we only line up all of the information from the right table. Or we could do it a right join, which essentially means keep all of the columns and information from the right table and then connect whichever ones line up. In these left and right join, you might find missing values, meaning that not every row lines up perfectly. And where they don't, if there's something exists, for instance, the mother's age was in another's data set. Maybe we had 2 data sets, right? We had one that was the baby and all of the features about those, the birth weight, the eye color, the hair color, things of that nature. And then we have another data set that relates solely to the mother, right? Her smoking habits, other characteristics about her, and we want to join the 2 together. And so, for instance, maybe on the mother's data set, they didn't fill in an age or certain things didn't line up. Like I said, if we do one of these left joins, right joins, or this outer join, there's possibility of having missing values or things that don't line up or perfectly in sync, and they're going to be filled in with null values, meaning we don't have it yet. And so at that point, it's good to understand the missingness of your data and why it exists, and maybe you can start to reconcile those things later on. If you do an inner join, this means find all of the matches that exist in both of the tables. So it's going to do the best to reduce null values or empties, because it's not just saying keep all of the information for one and line up where you can. It's saying line up where these things are perfect and try to dismiss the rest. So it depends on which way that you're trying to approach this. Some other things that you want to keep in mind: left on, right on. these are the key that you're going to be working with. So essentially, if I had, well, here I have the birthday of the week, and then I have the number, right? The birthday of the week is lined up with 1 through 7. As we saw before when we created this here, it's lined up with 1 through 7. So where it finds the birthday of the week from the left table and the number from the right table, where those two things sync up, that's where we're going to attach or merge the values from this, right? So if I see birthday of the week is 1 and number is 1, then I'm going to add Sunday and number to that row. So in this case, we have pd.merge, we have our original data frame, we have this day of the week data frame. We're saying left on this day of the birthday of the week here, right on the number. And if we scroll over, we can see that the name and number were appropriately attached onto merged onto the end of this data frame here. Keep in mind, right, like as I said through the whole thing here, this is non-mutating. So this is a new data frame that's coming out of it. And the original data frame that we had is right here below, right? So if I just do the DF, although we saw before that it was pd.merge, the DF and day of the week, this one's not affected. And if we scroll all the way to the end, we don't see the number or the day listed here, right? So if we wanted to do that, we wanted to save it, we would have to assign it back to this original variable name, or else it's just going to be output and it's there in the memory, but it's not saved to anything that we're working with. So it's also important, and some of these names are kind of obscure, and you'll see that if you work with any government related data or healthcare data, that sometimes the names that they give are symbols and things that they've defined, and then they'll have a data dictionary that'll tell you what is it that this column means. But it's important to, if that is the case, rename the columns that you have to something that's reasonable. And so one of the things that you'll see here is they're all lowercase, and they're separated with an underscore. And the reason for which is if I had a space in this name, it becomes a lot harder to work with later on. So the convention in Python is to separate lowercase names by this underscore so that we don't run into any problems later on where we're trying to do something. For instance, right, if I do df dot birth year, this gives me a series of all of the birth years here. We can see that it just pulls out that one column. But say I had a space here, right? There was a space in the name of this column. This would start to cause problems. I'm going to get an invalid syntax because this thinks this is a variable here, and this is me referencing a column from within it. So keep that in mind, that you want to separate out column names and variables with underscores, because you're going to run into problems if not. And if you find that you've loaded in a data set that does have them, you might want to replace them so that it's easier to work with. Essentially, we're just dropping. And what are we dropping? We have to reference the columns that we want to drop. We drop the number. We saw that was just 1 through 7. But again, that was redundant because we have this other column of birthday of the week, and that tells us the same information. So we don't want two columns that tell us exactly the same thing. Again, all of these are non-mutating. I come down here and we look at the end of this and we see that the number is mysteriously shown back up, and it's because the last operation wasn't saved to anything. And what are we doing in this case? We're just renaming something. And these are, for the most part, intuitive and in plain English. It just takes a little bit more time to understand it. Again, we reference what is the column that we're changing. We're changing the name column that we had before, and we're going to change it to the birthday of the week name. Kind of a excessively long name here. Please don't do that either. I know that when you're first going through this and you're creating your own variables, it becomes very commonplace to start trying to name it as explicit as possible. You want to be concise, but you also want to keep the length of it down and not just start going into this is my new variable. Yeah. And so if you want to rename them, this here looks like a dictionary, right? We have a key value pair, we have the name, and this is essentially saying that it lines up with this value. We're converting the name into this here. And so this could be done with multiple of them, right? I could have a comma here and say that I wanted to change something else, and I wanted to switch the number here, and I just want to call it something. And so, well, put me all the way back up there. Okay. So we had that, and right, I could change it, multiple of them. And so if I came to the end of that data frame, we would see that multiple things had been changed. And you can continue to do that with as many of the names that you want. Like I said, it's a good first pass when you come into loading in your data set and you want to change multiple names, because either they didn't make sense or you need to fix some of the characteristics of the way that it was spelled. And so we're doing those things together. We're dropping the number column and we're renaming the other one. And we can do that by chaining, right? We could do it one after the other. We don't necessarily have to have those in multiple steps. And so sometimes we might get obsessed with that and think that it's fun to do everything in one line. But that becomes a lot of, it's harder for, it's like a run-on sentence. It's harder for the audience to understand it. And generally, this is going to be your future self or other people that you're working with. So you don't always want to have it sweet, I did it on one line. Sometimes you want to separate them out, but it is possible, right? Essentially, we're saying take the first step here, drop this column. Like I said, that outputs a new data frame. What do we do to this new output? We're then renaming some of the columns and we're saving it back to the data frame. So we want to mutate that one. We want these changes saved. And now we just have the birthday, the week name, and we still have those values for the birthday of the week. We saw this a little bit earlier in terms of selecting and filtering. In this case, we're just subsetting the way that we did before. We have a list of the number, the names here, and we're saving it with, or we're subsetting the original data frame with whatever the column name subset is. And that just pulls out these few columns here, the 5 that we want to choose from. But sometimes we want to look for more than that, right? We're doing a data analysis and we want to check if certain conditions are true. And so an easy way of doing that, we saw prior that if I just, for instance, call the data frame and then I use the dot and then I choose the column name, I can do a conditional check here. And what I'm saying is all of these values, look at this. We have 1, we have 4, we have 9, 6. Are they greater than 6? And so if I run that, it'll do it for all of them. And so maybe we want to find people in a particular income bracket. And so we want to say that their income's above 60,000 or something of that nature. And then we want to subset the original data frame with that. And the way that we would do that is getting this conditional check. And the same as we saw before, putting it back into this index and saying that we want all of the rows from the data frame where the birth month is greater than 6. So these are babies that are born later in the year, July through December. And that's what will be output here. And we can see that the birth month is confirmed in that, and that we don't have anything lower, 5 or under there. We can also check to see if a value exists within a collection. And we do that with the is in, right? So we're looking at the name of the week again. We're saying, is it in these 3 values? Is it Sunday, Monday, or Tuesday? If so, if it's any of these, right? If it's Sunday or it's Monday or it's Tuesday, it doesn't have to be all of them because no baby's born on 3 days of the week at the same time. But sometimes you are looking for multiple values there. In this case, we just want to know, was the baby born on Sunday, Monday, or Tuesday? And it will do the same thing, right? We say, we take this long lengthy thing that we just typed out here. We subset the data frame with it, and only the babies that are born on Sunday, Monday, or Tuesday will be output and filtered there. And so we could just continue to stack these things on top of each other and create more complicated conditional checks. In this one, it's not too bad. We're only doing 2 of them. We're basically, and from math, right? Please excuse my dear Aunt Sally, PEMDAS, if any of you know that. It's order of operations. So this section here, we have to, the parentheses is the first one. We're saying isolate these 2 different conditions that we're trying to check. We're just trying to say, is the birth month greater than 6? And, right, and another one. So both of these have to evaluate for true in order to be returned. The baby has to be born in a month greater than June, and it has to be born on a day that is Sunday, Monday, or Tuesday. So the same as we saw before, the months line up with being greater than 6. And we get the baby was born on Monday, Sunday, or Tuesday. right? So now we only have 8,000 observations and 109 columns there. Don't worry, we're almost through this. We have some grouping and some aggregation, and then we'll get into the prettier part, which is the visualization side of it. But all of these are the steps that you're going to take as you go through working on the data science project. You're going to start with looking at some of the investigation of it, figuring out what the data set is that you're working with. And then you want to find some group patterns, right? What's the seasonality of the births for any given weekday or month? And what are some of the patterns that exist throughout the year? So in this, we're just grouping by the month, right? The numbers 1 through 12, and we're going to do an aggregating function after that. In this case, we're just counting. We want to count the number of observations that exist in each one of those groups. In this case, it's by month. And then we want to subset, and we're just selecting out birth year. And the reason for which this is the aggregating step that we're doing right now is a count, which means it's going to be the same for any of the data, any of the columns that we have, right? It's the same number of babies for each month, regardless of the column that we do. So if this was different, if this was like an average, or we were taking the sum, these might be different because it's then dependent upon the type of the column. But with the count here, it's really not, because all of the groups are this, or each one of the columns is going to represent the same observations. So all of these numbers are the same across the board. So we just want to choose one of them so that we don't get all of this repeated values. After that, we're renaming that column as we saw before so that it makes sense. And this is just the number of births. And now we have the babies that are born aggregated by month. And so for each of those, we have the number of births for any given month. All right. Again, there can be different aggregating functions that are put in here. Here we want to see the mean. So we're looking at, for any given month, what is the average of the mother's age? And for the most part, it seems to be consistent, right? 28 to 29 here. And so it doesn't really matter what month it is, the mother's age is relatively the same. Right, something like the number of birth is changing, it's seasonal, but the age of the mothers is consistent or pretty normal throughout any of the months. So we're essentially just, again, subsetting by the mother's age, and then we can just use the aggregating one right on that, because we've already stored it back inside this group by object here. We can also do that with other columns, right? We can do it with the birth name of the week. And this is what I was saying is, now we have values that kind of represent what we would understand as the days of the week or what their names are. And then we have the number of births there. It's not just the 1 through 7. We actually have these names that we can tie back to. And you'll see in the visualization side, that's kind of critical, right? Because if my x-axis is the day of the week, it's very hard for the audience that we're speaking to, if this is deliverable to our executives, to understand what the 1 through 7 means. It could be anything. And so in this case, we want to know explicitly what the day of the week is. Same here, we're just doing the same steps for the day of the week with the name rather than the number. Any questions on aggregating up until this point? I know I'm kind of cruising through this one. I want to respect your evenings and let you get to the afternoon. But we just have a little bit more here. So other than that, we can, again, we're just subsetting by a couple of the columns. And this is where we're starting to get into our analysis and seeing if the number of cigarettes that a mother smokes affects the baby's admittance into the natal care intensive care unit. And so there's another column in the data, or another category. Basically, it says U for unknown. We don't know if the baby was admitted to the intensive care unit, but that's very critical to our analysis. So we kind of want to dismiss those. We're not just looking at general cases of babies, but specifically, how does smoking affect the baby's chances or likelihood of going into the intensive care unit? And so we just want to make sure that the admitted value is N and Y for no and yes. So these are babies that we know very surely if they were or weren't admitted into the intensive care unit. The other thing that SIG's tree is the number of cigarettes that the mother smokes, and it ranges from 0 to 99 in this case. We can use this method here of value counts, and that'll essentially tell you each one of the categories and then the number of observations that fall into that category. So we can see that for the majority, 35,000, 36,000 out of the 38 that we have are non-smokers, and that's good. We want healthy babies. But then the other categories that come afterwards, right? We see 10 cigarettes a day, and I think it said after somewhere around 20, it starts, the count is by 5, and maybe even 10 after that. So you have to be aware that these things aren't linear. It's not just 1 through 99. That they're escalations in the count of the number of cigarettes that they have here. And some of the other things to note before we get into that analysis part is that we have an extremely low number of observations for certain categories. So this might show imbalance in our data set, and it might suggest that we need to collect more data because, again, we can't substantiate our claims if we have a limited number of observations in any given category. And that's kind of critical to doing our analysis here. So just a couple fancy things here that essentially are just maybe expansions on what we saw before. We're grouping by 2 things, essentially the number of cigarettes that they smoke and whether the yes or no if they were admitted into the ICU. This N size, or this size here, is doing the count that we did before, the value counts. So it's telling us how many fall into each one of those groups. So if they smoke no cigarettes and the baby was not admitted to the ICU, this is the number of cases that exist. Well, they didn't smoke cigarettes, but the baby was admitted to the ICU, and that's the number of cases there as well, right? So 10% of them, regardless of whether they, or if they didn't smoke, were still admitted into the ICU. Again, keep in mind, this is just 1% of the data set we have. So it can't be an accurate representation of it as a whole, but it just is showing us how to go through the process, right? Generally, you want to take a much larger sample of that. We reset the index, and essentially that's just taking whatever this value is. We saw before that we had changed it at one point to the number of cigarettes that the mother smoked, but now we want it to be a column in the data set. So essentially, rather than having the number of cigarettes that they smoke as the index, we want that to be another column that we can operate with. And we're just renaming 0 as number cases. It didn't really have any name on it before. It was just a 0th index column. And so we're renaming it to this number cases. This is where I might lose a couple of you, but those of you that saw it before, our code, maybe have an understanding of what's happening here. But essentially, we're creating 2 empty lists. And those are just containers, right? If we're going to organize our house, we have a bunch of empty boxes and we decide what's going in each one of those boxes. And so that's what we're doing here. We're defining an empty list called values, and then we're going to iterate over this admitted counts of the number of cigarettes that they've smoked. And we're going to place those or do something to each one of these empty lists and putting different values in there. And so the important thing to, as you work through these process, don't become overwhelmed when something looks very involved. You'll often go online looking for a solution, and it looks like there's a lot of information there, a lot of code that you don't understand. But it's important to just take out pieces of it and start to see what they do one at a time, right? What is this section here doing? So it says for value in this here, we're going to do something. Well, what is it that we're iterating over? It's just the number of cigarettes, the number of unique values that exist for the number of cigarettes that a mother could have smoked, right? So we have 1 through 10, 11, 12, 14, 15, 16, 18, 20, 30, and these groups here. Again, not evenly distributed. It's just the way that they decided to assess certain groups. So it's something that you want to be aware of in terms of doing that, right? And then vals.append means that we're going to add to that list. We're going to append something. we're going to append the value of this. So essentially, we're going to go through and 0, we're going to take that value, we're going to append it to this here. And the next iteration, the next time we go through this loop after we've created it, we're going to start with the next value that we've indexed, and that would be this one. So essentially, this vals here is just these unique values here as we go through it. We want to get the number of babies that were admitted, right? And so this is just saying this value or greater. It's taking a cumulative sum of the values here, and it has to meet this condition, right? We're trying to find the proportion of babies in any given category that were admitted to the ICU. So the admitted to the ICU has to be yes, right? Because we're more concerned about the babies that were admitted. And so we're just getting a sum of those, which is essentially saying out of all of these that this condition holds true for this category, right? This and greater, all of the ones that were admitted to the ICU, that's going to be our numerator. In our denominator, we're just looking for the number of babies that were here in this admitted counts in general, right? So we're trying to find the proportion of the ones that were admitted versus the total number of cases. And essentially after that, we're then just finding the percentage of that, right? Which we know is the numerator divided by the denominator. And we're taking all of those values and we're doing what is called zipping. Essentially, think of it literally as your zipper. It's taking one and putting it in front of the other. It's coupling these values together. We saw this before with the name of the week and the number that it was. We didn't zip in that case, but essentially that's what it's doing. It's taking these two different lists that we have here. We have this vowels and then the percentage here, and we're taking them and we're putting that as a row observation and creating a data frame out of it. Then we're just naming our columns. We have the percent admitted to the NCU and then the smoking level here. And we're calling this smoking risk. And so we can see, again, this is cumulative in this part. And that so as it goes up, the number of cigarettes that they smoke, there's an increased likelihood that the baby is going to be admitted into the ICU. I know I'm making this claim, but a couple things. Like I said, it's a subset, so we can't say that it's actually representative of the whole. It's only 1%, and just because there's a correlation here, when we see the number of cigarettes goes up, that the baby's admitted into the ICU, it doesn't mean causality, right? There is sometimes cases where there is correlation, but not causality. In a kind of an extreme case is the number of ice cream sales in comparison to the number of murders. And so, it's kind of a scary example, but as the number of ice cream sales goes up, so does the number of murders, as it turns out. But it doesn't mean causality. It doesn't mean that people buy ice cream because an event like that happened, or an event like that happened because someone bought ice cream. We can start to think about other causal relationships that are maybe related to both of those, but doesn't mean that they relate to one another, right? And so the obvious one is it's summer, right? And winter. So less ice cream sales in the winter, but also less people out and about on the streets. The temperature is lower, so people are less likely to be agitated and aggravated because they're sweating hot and they're running around New York City, and no one gave them ice cream, so they're gonna do something about it. So any of the claims that you make, any of the things that you look at, make sure you don't say, oh, that this is a causal relationship. And there are other tests and things that need to be confirmed in order to have a relationship like that hold true. All right, so we're in the fun part of it, the last a bit here, and thankfully you've stuck through it. And those of you who didn't, it's okay. You'll have recordings, you'll have notebooks, and so to visualize it, we're going through the same steps that we saw before, but the only thing that we have to do in addition to that is there's a method here that's plot. Like I said, this is using matplotlib under the hood, but it's just another package for data visualization. We have to specify the kind of the plot. We say that it's a line. We want to give it a nice title here, and we want to label the X and Y labels accordingly, because it's very important to the audience, right? If I have currencies, I want to put dollar symbols. If I have percentages, I want to put percentages. And I want somebody to be able to look at this and immediately figure out what's going on, and doesn't have to do any kind of extra legwork to figure out what it is that I'm trying to showcase. And so in this case, we have the month, we have the number of births. One of the other thing that's critical to this, and you'll, as a test to yourself, you can go out there and look at news outlets and any kind of blogs and articles that you read. You really need to be aware of the limits that are used on this y-axis here, because looking at this, it looks like it's a drastic change, looks like it goes up substantially in the summer, fall months here, and then drops back down substantially as well. But keep in mind, this is from 2,900 to 3,500. So the number of births, the range here is really only 600. It's not that big a difference. And if we were to change the access limits here, right, by setting the Y limit from 0 to 4,000, so that we encompass all the way from 0 to the number that seems to include that range, now the differences between these here look substantially less. And people can grossly misrepresent information if they don't have this axis lined up, right? So you can see people and go, oh, wow, we're having record sales. And then you look at it and, well, they've only increased by 100,000 when they're actually doing $1 billion in sales a year. And so we got to make sure that these things line up, right? It's very important to label them properly and not try to mislead your audience into a bad direction. So we can change the kind. Like I said, we can make it a bar plot here. And it's just a different way of visualizing this information. Perhaps we want to, now that we have the number of births in the months, maybe we want to add an additional layer on top of this, and we want to know the proportion of births that were and weren't admitted to the ICU. So we could change the colors here and do that category of yes and no, so that we could see, all right, is it going up or down for any given period or month, right? Are they more likely to be admitted to the ICU in the hotter months versus the colder months, or vice versa? And so you want to layer on different aesthetics to try to expand your analysis and be a little more creative than that. We can also make the line like this for the day of the week. Keep in mind that this here is lined up alphabetically, so this is not representative of what we would see if we were thinking about it from our human perspective, where we've labeled the days of the week in a certain pattern that we're familiar with. So this here, again, it's misleading. It might think that it's going down in the middle of the week or something of that nature, but these days aren't lined up the way that we would want them to be. So essentially, we can use this loc here. Again, this is another way of sorting. We're saying here's the order that we want them to be in explicitly, because this is what we're used to as humans and the way that we've labeled the days of the week. And so we want to take this, we want to locate it based on the day order. So essentially, location or a loc, this is a way of taking a named index here. Basically, we're saying to index this data frame based on whatever the values are that we find in this list. And so now this makes sense with what we understand and can use it accordingly. So now what we see, instead of that weird drop in the middle, we see this little hump here, right? And so the number of births on the weekend is lower, meaning that maybe there's a number less workers there. So maybe they schedule more during the week so that they can handle the volume. And no claims being made here, but that's just something that might be an observation of what we're seeing here. Again, we could just do this as a bar plot. Not much is changing there, but it's good to see patterns like this that exist. And again, we want to know trends. We want to know seasonality. Are these things happening repetitiously throughout the multiple years that exist? So the last part here, and just leaving you with the final analysis. Essentially, we're taking that percentage that we saw before that was in a table, and we're just plotting it here, and then adding this long title to it. So again, we can just reference that by the variable name, store it in this. And so we're essentially seeing that for the smoking level, someone who smokes no cigarettes, the percentage admitted to the ICU is 10% here. But we see these large spikes at 0. We see almost a vertical incline here around 10, and then 25 to 40 here. And so perhaps we can say, and can't justify this right now, but there are definitely kind of stepwise increases in likelihood of being admitted to the ICU given certain values of smoking cigarettes, right? So if we were going to run some kind of campaign, we're a hospital or we're trying to lower smoking levels and things of that nature, it would be good to know the sections of which we see larger spikes in percentages of individuals going to the ICU so that we can say where these patterns exist, right? Greater than 0, 16, 22 is where we start to see the risk jump up quite substantially. And so maybe we wouldn't define what that higher risk is. We want to figure out where is the percentage likelihood of being admitted to the ICU greater than a certain threshold. In this case, we're doing 30%. And so this outputs 18, right? This is where the point of which it's greater than 30 here, right? Around 18. So those who smoke at least 18 cigarettes in this given time period, whether it be a day or a week, are a much higher percentage risk of newborns being admitted into the ICU during the third trimester, right? So maybe that's when we want to start running some of these campaigns to suggest you shouldn't smoke you shouldn't smoke at all, but you shouldn't smoke during your third trimester because the baby's chances of being admitted to the ICU are a lot higher. And so we're essentially just tying this all together, all of the steps that we've seen thus far, because this is where we want to start this is the type of table that we would want to be able to output to do a thorough analysis, right? What are the number of cigarettes that the mother smokes? What are the proportions of the babies that were not admitted versus admitted? And then what's the total percentage for any given category of those that were admitted into the ICU? So that would be the thorough part at the end, so that we can start to make some claims about, well, what is it what are the patterns that have existed in this data set that we've looked at, right? After the smoking level of 10, the levels increased by 5, and the majority of the cases are concentrated around 10, 20, and 99. This is where we see the most things happening in our data set. And the risk does seem to increase with the increased smoking, of course, but we're at 1%, can't make any of those fully claims here, but with the code that we've ran, we know that there's increased risk for the babies given certain number of cigarettes. Most massive jumps we see are between 20 and 30. And so this suggests that with these super increased levels of smoking, there is a much higher likelihood of the baby being admitted into the ICU. So in general, I hope all of this has given you a comprehensive look at some of the operations that you would do utilizing Pandas, how you would take a data frame that is kind of raw in the sense that it doesn't have, we can't tell any statistics about it, but start to do manipulations and visualizations and do an analysis of whatever this given data set is. So thank you. If you have any questions, I'll stick around to answer them. If not, all of this material will be sent to you. So thank you for attending, and appreciate you being here. And thank you.